Hello, thank you for joining us today. My name is Jody LaPointe with the Technical Service Department at Coburn Supply. Today's video is going to cover Ruud and SureComfort 1516 SEER inverters. These are new units, just came out this year. It's going to be a long video, but you can start and stop it as many times as you like. And if you have any questions, you can email us at hvac@coburns.com. Thank you and enjoy the video. If you've been to the training class prior to this one, that's great. If you got the app set up on your phone already, that's really great. You'll hear me say this several times today. We want the app and your My Ruud account or My SureComfort account to be married together. That way, you can get into diagnostics. Otherwise, if you just get in without a login, you're a guest. A guest can do all the setup on the unit, but has no access to diagnostics or the PTS, product technical support stuff online. So just make sure that you get your salesperson to get you set up on the appropriate brand. So what we're going to go over today, we're going to discuss the advancements that Ruud and SureComfort has made in the years leading up to this, mid-tier inverter systems. We're going to improve the ability for you to be able to install the equipment and set the equipment up a lot faster than we did in the years past. Because if you remember right, how are we setting airflow on variable speed? What do we have to do? Stand on your head with the flashlight in your mouth with the little screwdriver and try to figure out if you're going up or down in the orientation of the unit, right? Well, now we're not going to have to worry about that because we're doing it from our phone. And we're not doing it in the attic that's 140 degrees, okay? We can do it downstairs. So that's a big plus to me. You know, if nothing else mattered, that mattered to me. Understanding the basic troubleshooting and service procedures. Hey, once you get your account tied to the brand account, then all you have to do is hit a little icon on the side. It gives you a code. Then you hit the icon on the side. It takes you into PTS, which is Product Technical Support. And it just basically tells you what the code is, why it's doing it, and how to fix it. Pretty cool, right? Okay, so we're gonna do an equipment overview this morning to kind of introduce you to the equipment. You've probably seen it if you've been to a class before. But like I said, some things have changed. We're going to look at all the outdoor components, indoor components, applications, installation, all the tools that we're going to need in the near future. You know what's coming in 2025? New refrigerant, right? So that means some of your tools that you're using today is not going to be compatible with the new refrigerant. Startup procedures. We're going to go through the operations of the EcoNet control, because these units can be either, most of them can either be EcoNet controlled or controlled by a two-stage thermostat. And then, of course, in the end, we're going to go through the troubleshooting procedures. So this is the sustainability, global progress for the sustainability. This is where we're going to eliminate the CO2 effects of our atmosphere, right? So all the government agencies and in the states and the United States is adopting all these rules so that we can reduce our carbon footprint. And by doing that, of course, it makes the world better, right? We put a lot of effort into that. So one of the things I want to point out is the Coburn's Connect icon over here on the left. How many of you have the Coburn Connect icon on your phone? How many have heard of it? No one's, you've heard of it. All right, so the Coburn's Connect app is your fingertips to get into charts, to get into how do I do that videos. We've got those, okay? We've got a lot of stuff, and I'm going to probably in the middle of the class today, I'll probably pop it up and show you a few things right before we get to the service that's going to help you. It's free to you. It doesn't cost you a dime. You can do everything from putting an order in to going and registering your equipment right here. We've got our mid-tier 16. So with the mid-tier 16 SEER heat pump, that is a 3-speed brushless motor, 16 SEER. Now you'll see the Bluetooth icons, and then over here to the side you'll see that not only can you use the Bluetooth, you can also use the Ruud EcoNet or the Sure Comfort EcoNet thermostat with that to do all your setup. And if you want a really nice thermostat, that's a really nice thermostat. The mid-tier 15 SEER, same thing, Bluetooth. Either one of the two thermostats can be used. Now, when you use a regular thermostat, you do lose a little bit of your functionality, okay, of the variable speed part of the unit. But we'll talk about that a little bit later here. Mid-tier heat pumps. Now, notice on the 15 SEER heat pump, remember I said 99% of all the mid-tier stuff is Bluetooth? That is the only one that's not right now. Okay? This unit is a 2-stage scroll compressor, not variable speed, so you would use a regular 2-stage 24-volt thermostat with that. And the setup procedures are the way they were before. And we jump into the 16 SEER. Now we've got all of our Bluetooth technology back, and twin rotary compressor, and either thermostat could be used on that. Looking at the nomenclature, nothing's really changed here except for some letters. You'll notice right here the A and the Z. Now keep in mind that if you have an A, that means all regions. Think about the United States with a line drawn down the middle of it, and California included in the southern. Okay, so the A means all the regions can use this equipment. If you have an N, that means just the northern regions. These northern regions, they can still use some of the stuff, the lower tier stuff that we can't use down here. And of course, you've got the refrigerant that's coming out. Now, keep in mind this too, that we made a lot of changes this year, and you probably noticed that, right? The manufacturer decided to make these changes now rather than wait until 2025 and have two, right? So all the equipment that we have today is ready for 454B, which is the new refrigerant we're going to put in, the new A2L. It's ready for it. All we have to do is change the compressor and add some sensors for leak detection on the indoor evaporator coil and the expansion device. A lot of the other manufacturers have re-rated their equipment, made this change, and now they're going to have to make the changes in 2025. So they're going to be stumbling around, hopefully, and we're going to be chugging along. So that's the whole idea. Anytime you see the two numbers there, that's your capacity of the system. A there for design series, if we make any major changes throughout the system. This is your voltage. Pay close attention to that, because I've had probably 2 calls this year where we've put 3-phase equipment in where it was supposed to be single phase or vice versa. And of course, this is your stage type, 1, 2, 3, 4, your stages. Your controls, if it has a C, means communicating, pretty basic. N is non-communicating. And then we have another design series code there in the end. Just so you kind of understand what the nomenclature is telling you when you're looking at it. And all of our units in the spec sheets of that particular unit, whether it be a condenser or a furnace, an air handler, or a coil, we have one of these charts in each one of them so you can tell what each one of those letters means. So looking at our M1 gas furnace. Now, in the M1 gas furnace, we have our 98%, 97% up here. These two furnaces are not Bluetooth. They are the old, I say old, they are the previous model as far as the board goes. It is EcoNet compatible, so we can use it with the EcoNet controller. The Classic Plus, which is our mid-tier 96% and 80% furnace, these are Bluetooth and EcoNet because we're using a constant torque motor. Of course, nomenclature on that same thing. As you look at it, you see pretty much all the same thing, the BTU, the stages, and so forth through there. On our evaporator coils on the mid-tier, you want to make dang sure that if you're putting in a mid-tier system, that it has the tonnage like this: 25, 37, 49, 61. You remember we used to do that in our product, right? When we were coming up between 13 and 15 SEER units way back when. So if you're putting in a 3-ton and it says 36, it's not the right unit, not the right coil. Okay? So just keep that in mind. The 37, 49, that means it's the high tier stuff. The Z just means it's the new M1 series stuff. Now, if you've been to some of my furnace classes, you've heard me talk about this before, but we're talking about matching that coil to that furnace. When we go and do something like this, it is okay? But if we are 2 sizes larger than the furnace, we're going to require a transition. And that's nothing new. It's been in our installation manual for a long time. Whenever you move air across these heat exchangers, you know they're tubular, and some of them are sitting sideways. The air takes a lot of turbulence, and it's a lot of turbulence in there, in that plenum, when we're going from the coil, the furnace to the coil. And then I've seen it to where the coil is pushed over to one side. Now, if you're using an end coil in there, if you have it pushed over to one side, we miss a whole slab with that furnace. Okay? So that causes us to have low pressures. I mean, I've done it many a times. I get a call, man, I put this unit in, it's running low pressures. I said, just take me a picture of the install, and they'll send it to me. And I'll see that furnace with the coil straight shot all the way, and this much hanging over the top. That means that much air is not getting to that coil. So that's going to cause us to freeze the coil or run low superheat, subcool, stuff like that. So we say minimum of 6 inches. You can go as high as you like. It doesn't matter. But we're going to start stocking these. Okay? So they come in a box. You just snap them together. You can keep one on your truck. It's not big and bulky. So it's a transition to go from the furnace to the coil so that we have a perfect line. Plus, you have a place to take static pressure, because when you take static pressure on a gas system, you have to go in between the coil and the furnace, right, in order to get the whole reading. This is the evaporator coil nomenclature. Remember I said this is important too, because we have the type of coil here, an A coil or N coil, whether it's vertical or horizontal or either way, multiple poise. The last one is whether it's a case coil or uncased coil. And of course the T over here, the T and the E means the metering device that it's got, whether it's an electronic expansion valve or a thermal expansion valve. The air handlers, the new M1 air handlers, is the RH3VZ model, and it is Bluetooth and EcoNet. All of our air handlers are designed to go upflow or horizontal left, and then you have some modifications you have to do to go right. You probably have already done that before. It's fairly easy. It's not that hard. You can turn the coil around and go right-hand position if you like. Now this unit has a constant CFM PWM type motor, so it's variable speed. And the nomenclature for the air handlers, RH, that really didn't change for the brand and the product type. Number of stages. So you notice this one was a 3, so this is a 3-stage unit. And the motor type is variable speed. And then as you go down, everything pretty much lines up again as far as all the other equipment goes. The BT is the size of the coil and what type of coil is in there. On the mid-tier inverter matchups on the condensers, everything is going to be Bluetooth and Econet from the air handler, the RH3 air handler, all the way to the 96.2V gas furnace, as we talked about earlier, for the 16 SEER. And then the 15 SEER matchup goes all the way to the 96.2V here with all these matchups here that are Bluetooth and Econet. Now here you see the last 2 furnaces here and the last 2 over there. Those are Econet only setups. Here's the RP or the UP16 and the 2 matchups Econet. You see the last 2 Econet only on those 2 furnaces. But looking at the outdoor components of the units, you're going to see a few things in here that's going to say, whoa, what is that? So we have our inverter board there, that big red board. That's the inverter board. Over here on the right, you see a capacitor and a contactor, right? Does that raise a question? Wait a minute, that's an inverter. Why does it have a contactor and a capacitor in it? Both of these are supposed to be variable speed. That's part of the 3-stage operation. The contactor, when the unit runs and it gets up to 75% on the inverter, and you have to go into 2nd stage, let's say, whenever that thermostat says it goes into 2nd stage, then it turns the inverter off and pulls in the contactor. I'm going to say this about a dozen times today. Do not push that contactor in while the unit is running in the inverter. There's no serviceability, nothing for service that matters if you push that contactor in. Other than when you push it in and the inverter's engaged, it blows the smoke box out of the board. That's out, and it can't be put back. It has a cap on it. It's got screws. We're all guys. There's a button under there. We know there's a button under there. Being that we're men, we're going to take a screwdriver, open it up, and push the button. We got a ferrite ring. Ferrite rings are made out of kind of the material that magnets are made out of, but there's different types of them, and what they do, they eliminate RF. So anything that is going to attack the unit being RF or E, it helps quieten the unit down too. It keeps noise from interfering with anything. That makes sense? It's a ferrite ring. We have our terminal block down here. Redesigned that, put it on a metal bracket there. Right here at the top, you'll see that Mobus, that J130. That is a jumper that goes from this board on the right side over to the inverter board. Brings communications back and forth to the 2 boards. Okay. We changed the name of the outdoor control board to a universal outdoor control rather than a variable speed outdoor control. We did that because it's interchangeable throughout the whole line. Okay, you can. That's the same one that we're going to use on all of these units. So there's no more of the little memory cards that you had to put on them. Everything is burned into the board. So when you get a board, it's going to be blank. There's nothing to be on it. When you put the new board in, you're going to put in the serial number of the unit on the app and scan the board, and it's going to load that information from the app into that board for that unit. So it burns the serial number in it. The days that we kept a board on our truck and we put it on there just in case it was bad and we found out that it wasn't the problem, we pulled it off, put it back on our truck, those are over. Because once you burn that serial number in that board, it's no longer removable out of that unit. Okay, it has that unit serial number married to it. So if you put it somewhere else, it's going to have the wrong serial number, and you can't overwrite that. Here's our power input to the inverter board here at the top. 208, 230 volt, single phase, plus or minus 10%. Then you have that RS485 plug there. That's the Mobus plug that brings communication back and forth to the board. Right below that, we have our high pressure switch. We have our relay coil connection. The relay coil is a solenoid coil that equalizes the pressure on the compressor, and we'll show you that here in a minute. Bottom is where the fan motor output is. So this board is going to send PWM signal out to the motor so the motor can run in whatever speed this board needs it to be. It will always be engaged, so whenever the unit goes into high speed, in other words, it goes up third stage, is basically if you have it on the inverter. The fan output still comes from the inverter, so it doesn't completely kill it. All it does is take the compressor out, switch the compressor over to the capacitor in contact. And of course, here on the right, here's our compressor output. You'll have two outputs here, one for going to the compressor from the inverter and one going to the compressor from the contactor. And what basically happens is if you do push the contactor in, it takes the power from the inverter and the power from the contactor and capacitor and puts it together. And that feeds back into the board, burns the board out. And that's not covered under warranty. Here's your high pressure switch on the board, and there's that relay coil we talked about a little closer up. Now the high pressure switch is an automatic reset switch. It opens at 610 pounds and resets again at 490 psi. It's only considered during a call for the compressor, so it won't open unless it's got a call to the compressor operating. The backside of the inverter board, we've added some features to it. We had a lot of, especially in southern Louisiana and in our area here in Texas, where frogs and lizards and creepy things like that would crawl up underneath this inverter board and short it out. These plastic end pieces here will keep those critters from getting in there. We do still have the heat sink. This part goes into the condenser part of the unit. We need to keep this free of dirt daubers and spiders and stuff because this is what cools the inverter. That inverter puts off a lot of heat. So keep this clean. It can get wet. I would advise you not to take a water hose and spray it directly on there because there's a gasket around it. Okay? If you put high pressure in there, it could seep, but I wouldn't chance it. I would just brush it out, rinse it off real good, not with the power hose or anything. This terminal block will come off, but you notice all the writings here, so just be advised that when you pull this off, you want to make sure of the orientation so we know what each terminal is. So right now, if you pull that thing off, make sure we're putting everything in the right place. Now, the only thing you're going to have going to this outdoor unit is going to be E1 and E2 and R and C. You got 4 wires going out there. Looking at all the connections on the board, if we go up to the top, that Mobus connection there that talks back and forth to the boards, there's the connection for that pressure relief valve. Of course, ground, high pressure control, reversing valve down here. Liquid transducer. So we've got some transducers on here. The transducer is what reads the pressures in the system. Okay, so if you had your phone opened up to the diagnostic app on this thing, you could actually see the pressures the unit's running on your phone or on the EcoNet controller, whichever one you have hooked up, which I think is pretty cool, right? You can tell what your subcool, your superheat is all right there just by looking at this. Because we have the transducers and we have also the sensors, the thermistors, for both liquid line and the coil temperature on the suction line. We have an outdoor temperature sensor that senses the outdoor temperature and a discharge line sensor that senses the discharge line temperature. And right there at the top right of the board is the Bluetooth transmitter. I have a board set up where we can play with it, but the Bluetooth transmitter, I used to think, well, they say be careful with it because you can knock it off. And I said, no, it's too much well protected. Well, I've been carrying this board around with me for 6 months, right? And I broke the Bluetooth board off. I had to rob Rick's. But it's not the end of the world. It just means if you break it off, it just means that it's not going to travel very far. The signal's not going to go far. You'd have to get right up on it. But I think the only time that's going to happen is probably changing the board, moving it in and out. The board we used to call the variable speed outdoor unit control. This board, of course, is the one we changed, and the acronym for it is UODC, Universal Outdoor Control. This is where the little screen used to be that gives you diagnostics. And over here somewhere is where the memory card used to go. That's not in there anymore. All the diagnostics are going to go to Bluetooth. So that's the reason why we keep saying get that app on your phone, get it married to the account so you can get all the information you need. If this board is ever replaced, it must be set up via Bluetooth. That's what I was telling you a little bit before. You put the model and serial number of the unit in there, and it takes all the information that needs to be in that board for that particular unit and loads it in. And that would be like fan motor speeds, what tonnage the unit is, all that would be loaded in there. More expanded information on that is in the contractor app. It will walk you through doing it. It's pretty easy. All the sensors on our system, we didn't change the plugs, we didn't change the sensors. They're all interchangeable. The LED lights on the board, these are not diagnostic lights. These are lights telling you what the board is doing, whether it's in cool, whether it's in heat, what speed it's running at, or the capacity. As you see, the green light there connected whenever we have a Bluetooth. So this is the Bluetooth light. Whenever you have a connection on Bluetooth, it turns solid. Whenever there's no one connected to it, it's blinking. The next green light is the cool light, and one blink for every 10% capacity. So every 10% capacity, it's going to blink. Let's say 7 blinks, 70%. And you'll see on the chart what stage that'll be in here in a minute. The amber light is just like the cool light. It's the heat light. It does all the functions that the cool light does, just in the heat mode. So if we're going to do any diagnostics on this unit, this is an important chart. I'd get your phone out and take a picture of this screen, because it's always good to have that information right in front of you whenever you need it. I'll leave it on the slide there for you to do so. So looking at the different wiring configuration, you can see that the 1, 2, 3, 4, 5, 6 starts here, and 1, 2, 3, 4, 5, 6 starts at the bottom there. So if we go to terminal 1 on this board goes to number 2 on this one. So on this one, we're going to measure 18 volts DC. 3 goes to number 3 on the board, and that is our 18 volts return back to the other board. If we go number 4 is the RS485 connection. That's the negative side of the bus. And then number 5 is our common side of the bus, and it's number 6. But the ones you really have to make most concern about is number 1 and number 3 on that side. Because that's going to be your voltage going and your voltage coming back. If you've got voltage going to a board and nothing coming back, chances are the board it's going to not coming back from is bad. If you don't have anything going to it, the board's sending the signals. This is the contactor. Notice it's sealed, but it does have screws that can be removed. If you change this contactor, we need you to go back with the same exact contactor. We want it covered, right? And we want a 2-pole contactor. And again, you're going to see this a lot. Under no circumstances do we ever push that contactor in. It could and will possibly cause bodily injury, and it's going to kill the board. So, and once damage is done to the board, it can't be repaired. It has to be replaced, and that wouldn't be covered under warranty. A twin rotary compressor is made The brand name is Highly. It's been around a long time. They use them in mini splits. Basically, you've seen those. It's a regular PSC compressor. It's not a typical three-phase type compressor you're going to see in variable speed. Right? It has POE oil in it. It's R410A, 208, 230 volt, plus or minus 10%. It's single phase, and the frequency is 60 hertz. On the side of the compressor, you notice we have an accumulator. This is to recover the oil back to the unit and take any liquid that may be in the suction gas to keep it from getting into the compressor. Because just like a scroll compressor or any compressor, we're not supposed to have any liquid at all in the suction line. The top of this container, as you can see, it has a semi-sphere up here, a little cover plate and a screen that goes over the top of the two pipes. That's to keep the liquid and oil from going directly into these pipes. At the bottom, you see some oil return holes. This is to pull the oil out of that accumulator at the bottom to get it back into the system. You notice it has two suction lines coming out the bottom going into the compressor. The 2-ton is only going to have one, but we need the volume of refrigerant coming out for anything bigger than a 2-ton going into the twin rotary compressor. Here's a cutaway of it. It's blue here, but it's going to be black. This is just a cutaway version. But as you can see, we got our discharge line there at the top. We have our rotor in the middle, the blue. Then we have our two stators on either side. And then our crankshaft. And then we get down here into the upper and lower suction port where it comes into the rotors down here. And you see the accumulator over here. Each one of these has its own chamber, I guess. There's a vane in the middle of this. So it's basically like two pistons. Yep. Here it is in operation. As you can see, there's the discharge port on the right, the suction port's on the left. And right here in the middle there, you see that little thing going up and down? That's the vane, or the valve, that's going to separate suction from liquid, high side from low side. So, think about this. We're brazing a unit, and all that black stuff that comes off on the inside too. POE oil washes it off. Where does it go? Oil. What's going to be the failure of this? You got it. That vane right there. All it takes is it getting stuck. If it don't come back out, we don't have a pump. That solenoid valve we talked about earlier equalizes the pressure across it. The compressor will not start pressures across these two. Discharge port and suction port is more than 20 psi. Mm-hmm.
So when you shut a system down, you have to let the pressures equalize.
Yeah, well, this valve is going to do it automatically. It's going to lock it out until it does it.
So it automatically locks it out.
Every shutdown, it opens that thing and equalizes it. So your discharge port, your suction port, right here on the sides, your twin rotors here in the middle. Here's just a bigger version of it. You can see both the lower rollers and the upper roller with the cams there just pushing back on the vane. So we have mainly three compressors that we're going to use in our system. Okay, the first one you're used to all the time is the Coburn K7. This is a typical two-stage compressor with an internal overload, just like you're used to using now. The middle is the Highly, that's the twin rotary. And then this one on this side is the LG, which is, if you open it up and look at it, it's almost identical to the scroll. It operates the same way as a scroll. The way to determine them is the solenoid. If you look on the outside, this one has an external solenoid. That one's internal. You can change the coil on this one. You can't on the Copeland. So you'll see that out. So you can't change the valve, but you can change the coil on it. It's got just a 24-volt coil on it, where that's a DC coil inside that compressor. So we're taking 24 volts from our board going to this compressor. Right at the plug of that compressor is a rectifier. It changes it to DC. So if you've ever had a short in the system and you couldn't find it, I bet you anything it's in that rectifier. We got a video. Okay. So looking at the two-stage Copeland compressor, its refrigerant type is Lin 410A. We have a POE oil in it. Now I'm going to tell you, POE oil, it's a solvent, but it has oiling factors in it. A DC solenoid here on the outside. It's a regular 208, 230 volt single phase compressor, 60 hertz. As you can see the internals here, I've got one over here broken you can look at too. I'll show you I even tell you what caused that. But here's your scroll set, and then you're right at the outlet of the discharge line, there's a check valve in there. If you're ever changing a scroll compressor, keep that valve very cool. In other words, wrap a wet rag tight around it, keep it wet. Because you can warp that valve in there. It's a plastic valve. Okay, so if you're changing out a compressor, always remember to protect that thing. And if it warps, then the compressor is gonna sing to you when it shuts down. We have our compressor terminal plug over here. That's the plug that plugs in for high voltage. We have our solenoid terminal that plugs in here, another plug that plugs in. This is our rectifier plug. And right here at the bottom, we got this little device called a suction funnel. Now, a suction funnel takes all the suction gas, and remember I said gas, right, not liquid, and forces it up to the scroll plate. Where before, the suction gas would come in and kind of drop to the bottom. If it had any liquid in it, the motor down here, the heat of the motor would dissipate it. It no longer does that. It comes in and goes straight to the scroll plate. So if we're charging this unit, let's say you open the valves up in the winter and immediately turn on this unit. You're going to get a slug of liquid through here. And when you do, this can happen. This is what the scroll looks like. There's two plates. One that goes over the top of this and this one. And whenever you introduce liquid into it, the other one looks like this now. And you're going to get all these little pieces is going to fall out of that compressor into your suction. That is from liquid floodback right there. And it didn't take long to do it. That stuff will fall down into the suction funnel and out into your suction line. Not knowing it, you change the compressor, you start it up, and one of those pieces goes into the scroll plate. Now we just killed another compressor. So I'm going to tell you, always make sure there's nothing in that suction line if this ever happens. Let's move on to the outdoor motor, the BLDC. The outdoor motor is a brushless DC motor. You'll commonly hear us say BLDC, which means brushless DC motor. It's actually a three-phase motor. If you had to check it with your meter, ohm and out, equal on all three legs. Just like you do a compressor that's three-phase or something, any three-phase motor. The fan RPM is determined by the frequency. So in other words, that inverter board sends a PWM signal, which is frequency, basically from like 40 hertz to 60 hertz. It changes that frequency, and it causes the unit to be variable speed. Quieter operation, higher reliability, and it's a lot lighter than regular motors too. I don't know if that has a plus for you, but the PSC motor is a lot heavier. They're a lot heavier when we put the ECM module on the back of the motor, and then plus it makes that motor stick further down into the unit, right? So now you're going to see just the motor there and a wire going from the motor to the board, and the board's going to control it. So looking at the pressure relief valve we talked about earlier around the compressor, we were just talking about this. It's mounted here. Okay, and it ensures that less than 20 psi differential is across the compressor suction and discharge, or the unit won't start if it's greater than 20 psi. It's a normally closed valve controlled by the outdoor control board, and it has a 24 volt plug that goes to it. It's just a regular 24 volt solenoid. It's a removable coil. It can be replaced. It will open during a 5-minute off delay. So in other words, it will open up, relieve the pressure for about 30 seconds. You'll see these little tubes brazed onto the end of the coil. That's where the thermistor slides into. So you'll see this little brass or stainless steel clips that sensor, and it pushes it up against the line inside. So we have a good thermal sensing device right there. So that is the tube for the sensor for the expansion valve, and any thermistors that you see out through the system is going to be in this. We did change all of our condensers to 7mm copper. Everybody knew that was coming, right? We talked about that way back when. Going down to 7mm, we use less refrigerant. We don't have to have a condenser this tall. You'll notice our condensers are going to be smaller in the M1 product because we have 7mm copper, holds less refrigerant, and we don't have to stack the coil.
What's the wall thickness compared to the other?
It's the same.
Is it?
Yeah. I mean, it's still the same rifle tubing that we've always used, same thickness. It's just a smaller diameter. We can get more tubes in a tube sheet, less refrigerant, single row coil. If you ever try to clean a double row coil, you know what I'm talking about. So that's the condensing unit. Let's move on to the coil, the furnace and coil. The furnace control board, still mounted in the blower compartment. This is going to be the 80%. So your inducer is going to be pretty much the same. All the pressure switches here, the rollout switch, gas valve, burners. One of the things that we did to make it easy to service is that we've taken the pressure switches and the limit switches, instead of it being a daisy chain across all these switches and back to the board, each switch goes to the board itself. So that means in the diagnostics, it's going to tell you which switch is open. So there's no more, trying to find that dang open switch in there. It's going to tell you what switch opened, what switch is giving you the problem, or if it's still open. Same thing with the pressure switches. The low and high pressure switch is wired separately, so you'll be able to tell which one is tripped or which one is giving you troubles. Your app will also tell you why the unit's running. This switch is closed, this switch is closed, and you can monitor all the switches in there through the app. Still spark ignition. 90% furnace is basically the same thing. Now, this is what I was talking about earlier when I said in coil, right? You can see that if this furnace is 2 inches this way on this coil, you can see it's not going to get airflow here, right? And that's a big deal. I see that a lot on install. All the mid-tier stuff have thermal expansion valves on them with external equalization. We don't have to braze the valve in. It's actually the bolt-in type. It's mechanical fitting. Easy accessible because we put it in here. It's not tucked behind all the tubes and everything in there. We put it up front so you can get to it. And again, we highly recommend using either the center position of the furnace or use a transition, right? We want you to use a transition. You'll see, you'll get better airflow out of the system and better control the superheat on the coil. On the furnace control board, you see at the top row, that's all the safeties coming in up here at the top. We have our low voltage terminals coming down the left side there. And then we have our terminal block. This is where your E1 and E2 communication circuit control is going to go, and your 24 volts to your thermostat. All that's going to go there. Right down here, you see the LEDs that's right here. The Bluetooth LEDs here. Auxiliary terminal switch. Now, the auxiliary is where we're going to hook our condensate switch up. Because this unit is a communicating unit, even though it's a regular thermostat, it's still communicating. We cannot break any of the thermostat wires. The E1, E2, R, and C, it will not allow us to do that. We have to take our switches to the auxiliary port, The CS means condensate switch. You're going to hook it up there. On the bottom is a common, so it would go here and here. And then we have an auxiliary. That could be used as a secondary pan switch or whatever you have. You can put that there. Right below that is where the outside air sensor goes. Looking at the right side, there's more safeties at the top. This is our flame sensor and gas valve. Humidification terminal. That's humidification, not dehumidification. The next terminal here is our electronic air cleaner. And then right below that's our line voltage terminals. And then as you can see, more safeties go into that plug there where we have our flame sensor gas valve like we talked about. Humidifier, if you're going to use a humidifier, this is where you hook it up, not a dehumidifier. Inducer is going to hook up here. Our blower motor goes there. Neutrals, spark ignition, and Bluetooth antenna, as you can see right there at the bottom. The indoor blower motor, you see the bell end is still on these motors, so we still have the variable speed motors, but it's all made into one. Air handler, control board, fan motor, indoor coil. Hey, it's basically the same. You see the terminals here. You have the humidification terminal up there for it too. You have a terminal for the electronic air cleaner on the air handler board. You do have a place for the EEV. If your unit was an EEV, this is the same control that we would use. Float switch, just like we talked about on the gas furnace. Electric heat switches. Now, the electric heat, how many of you had a situation come up where the plug from the heat kit wouldn't plug into that board? We're dwindling through that right now, so we're probably not going to have to wait on it much longer. But the new heat kits, when you plug it into this board is going to automatically recognize what size heat kit. The heat kit has to end in a B, not a 1. So if you get a heat kit with a -1, it'll plug in, but it won't work because it's made for the non-Bluetooth units. The B means Bluetooth. So if you've got one of the mid-tier stuff with Bluetooth, make sure it has a -B on it. Again, Bluetooth antenna at the top there. We have our outdoor air temperature sensor, supply air sensor, and return air sensors here on the right. We do offer hydronic coils for if you have hydronics. We do have an air handler that has that, where you can put your water temperature sensor there. So that's suction pressure sensor, suction temperature sensor, and an electronic expansion valve will plug in right. Low voltage terminal block down here, E1, E2. Just remember, 1, 2 has to be on 1, 2 on all 3 pieces. Evaporator coils, 100% aluminum on the tubes. Mid-tier TXVs or external equalizer, non-brazing, and they're all easy accessible here because everything's up front. Nothing hidden behind all the tubes and everything. Heat kits, the new heat kits will auto-configure their size and airflow during setup. So if you had a Bluetooth unit and you had the correct heat kit in here, the B, then once you plug it in and turn it on, it's going to automatically recognize what it is and what the airflow needs to be to go through it. Now, installation process. Let's start at this. Now, this is going to be elementary to some of you. You know, we start off by taking out all the Schrader valves, right? Because when we heat this thing up, it's going to do what? It's going to melt, right? We need to deburr these things, being careful not to get any of the shavings down inside. If you don't deburr it, you know, smaller tube copper, it could show some type of restriction there, especially when we're trying to flow a high velocity amount of refrigerant. We want to use some type of rag. This is a bad example because we want some kind of cotton rag that's going to hold the moisture in, like a terry towel or something. There's a good rag here, wrap it, or any kind of thermal paste that if you have a favorite thermal paste and you know it works well, use it. We've got to keep these valves cool. If we don't, we end up with warped threads in there, and they're hard to get open, hard to get closed, or the seals melt. So we've got to keep them good and cool. We want to flow nitrogen through the lines as we're brazing. How many of us do this practice already? Oh, guys, I want to see that hand. Because if you don't, you know all that black stuff that's on the outside? That's on the inside too.
Absolutely.
Okay? And what did I say what this oil was in this unit?
Solid.
A solvent. It's a cleaner. So as it flows through this system, what's it going to do? Shine it up pretty clean, right? It's going to be real pretty in there.
And flush it straight.
And flush it straight to all your orifices.
I haven't had a TXV failure or a compressor failure since I started.
Congratulations. That's great. That means that you're doing something right. That doesn't mean that you're not going to ever have one. That happens, right? But whenever
I've on one of my installs, I have not had a compressor or a TXV failure since I started flowing nitrogen.
Flowing nitrogen. That's right. There you go. Because this is what we end up with. When we reuse a line set that's had mineral oil in it for 30 years, mineral oil will coat the inside of the line. And whenever we put oxygen in acetylene or air in acetylene to this, without nitrogen, this is what we get. Even if it was new copper, this is what we get. Perfectly clean, pretty much, and then perfectly dirty. And both these were new line sets. So how much of this black stuff's going to be there if that was a reused line set? All right? Because all that oil that flows through there is a solvent. It's cleaning that line set up. And eventually, the inside of that line set's going to look like that. So when you go to change that compressor out, because the compressor failed, because the expansion valve failed, slugging the compressor, so we had a chain reaction there, right? And it's all due to this stuff right here. So we braze about a half a psi of nitrogen through the line. Free flow through the line as you're brazing. It's an inert gas. It won't let the stuff in there oxidize. It's in there. Hopefully we have one of these on there. This is not a television. This is a micron gauge. If we're not using micron gauges, guys, we're way, way in the past. I mean, we've got to use these things. We've got to get it down to 500 microns, knowing that we have all the moisture out. Now, if we just take a typical system where we live today, and it could be a morning like it was this morning, real foggy outside, that means there's a lot of moisture in the air, right? And all the moisture is right here where you're working. And we pull this thing down to 500 microns and think we have it good. We shut our valves off, and guess what? Pressures come up, right? We think we got a leak. In reality, we have moisture in the system. And when you pull that copper line below atmospheric pressure, whatever moisture's in there is going to freeze. So when you start getting below the atmospheric pressure, we're going to start freezing that moisture in that system. And then when we put refrigerant in it, it goes back to water. Now we have water in our refrigerant. So how do we get it out of there? Well, we're going to do a triple evacuation. Doesn't take long to do, because the first step is just pull down to 2,500 microns. That's nothing. Okay? And then once we reach 2,500, we're going to break it with nitrogen. And we're going to pull it down to 1,500 microns. We're going to break it again with nitrogen. And then we're going to pull our 500 micron vacuum. So each time we do that, we're getting more moisture out, more moisture out. We're putting dry nitrogen in, which is drying it out, pushing that moisture back out. And now, when we pull down to this 500 microns, you're not going to see your gauge come up much. Maybe a little bit, but not much. Let's get into wiring the thermostat. This is what we just talked about a minute ago. We use just regular 18 gauge thermostat wire, just like you're used to using. Don't use anything like phone cord or 20 gauge wire or whatever. We want to use 18 gauge, real good thermostat wire. The Econet control systems requires wires for operations R, C, E1, and E2. If we've got it on a 24-volt system, then you're going to have to put in the other wires, and we'll talk about that in a minute. But here's your typical setup for an Econet system right here. Econet control, Econet inside, Econet outside. So if you're going to put an Econet control with any of these mid-tier units, except for the heat pump on the 15 SEER, this is your wiring schematic. That's all the wires you need. On the board, you can also see what we call load shedding terminals for the utility U and U2. In areas around Texas right now, like Austin and some of the big metropolitan areas, they want that control. They at the very inopportune time, like when it's really hot or you really need the air, they're going to turn it off, right? Because we don't have enough power to supply the grid. Here's a typical regular thermostat 24-volt system hookup. As you can see, here's our outdoor unit, E1, E2, R, and C, and then that goes to the indoor, and then we've got our RC, Y1, Y2, reversing valve, and heat strip wire going to the thermostat. Okay? So all the communication, even to turn the heat strips on during defrost, is going to come through the E1 and E2 bag. It's a lot less wires you have to deal with outside. On the air conditioners, the same thing. All of our wires are going to go from the thermostat to the air handler on a typical thermostat, and then our E1 and E2 and RC comes to the outdoor unit. Now this is on everything except for the 15 SEER heat pump.
What's good about those is you can't hook them up wrong. If you do, it won't work.
That's right. That's right. If you get them backwards, it's just not going to communicate. Not going to communicate. And don't think that just because you ran brand new thermostat wire, that thermostat wire doesn't have a problem with that communication. It doesn't take much. You know how you can step on a piece of thermostat wire and you push the wires together? And it's just a barely touch. That's all it takes to kill that communication. Just a little bit. I've gotten involved with systems that have had thermostats changed, control board changed, and now they're saying nothing works. We want a new unit. And I said, did you change your thermostat wire? It's brand new wire. I said, change your thermostat wire. So whenever we're doing zoning, do any of you do zoning? Some. With the mid-tier stuff, we're allowed 2 zones and a bypass. Now on the full EcoNet high SEER stuff like 18, 20s, those you can run multiple zones on them. But just be cautious how you do it. You know, we don't want to zone just the master bedroom because they want to keep it at 68 degrees at night. Because we all know that that's going to be the only zone called on, and that duct's not going to be big enough unless you put enough duct in there. You know, so just be careful. These units are smart enough to protect themselves. If that evaporator coil gets too cold, it's going to shut it off. If our static pressure is too high going through the zone dampers, it's going to shut it down. It's going to tell you that you don't have enough air. It's going to protect that compressor as much as it can, right? That's a lot of my callbacks on zone systems. Well, the other one didn't do it. Well, this unit's a smarter unit than the other one, right? It knows when you're going to kill the compressor. We talked about tools. Not only do we have all these new tools to work on current models, but what's going to happen in 2 years, well, not even 2 years now, a year and a half, when we go to the A2Ls, right? We've got a flammable type refrigerant we're using, so we're not going to be able to use the vacuum pumps, the recovery machines, the leak detectors that we were all used to using in the past, okay? So I just want to caution you, if you have to purchase a new tool right now, don't go buy that discounted model that they've got a really good deal on now because they're getting rid of it because it's not going to be any good in a year.
So have all of the manufacturers gotten together and decided what the refrigerant they're going to use?
They haven't got together to do nothing. Most of the manufacturers are going to use 454B. You've got other manufacturers, they're going to use 32. But going to the mixture refrigerants, do you know what 410A is made out of? R32 and 125. Right? 125 is like a fire suppressant. You use it to put out fires with. So they put those two together, made a really good refrigerant. The glide on it's not real wide. You could top it off if you needed to. The new refrigerant's coming out. You better start reading up on it because it's going to have a higher glide. You're not going to be able to top it off. R32 is one refrigerant. 454B is a combination of R32 1234YA. So 1234YA is what's in your car right now. That's what they changed 134 to that.
What do you mean top it off? You like if it's low, just add a pound?
Refrigerant 410A had two refrigerants, and they had a near exact boiling point. So it was called an azimuth. Two refrigerants, one boiling point. So when they leaked out at the same rate. Any of the blends that we've had in there are zeotropes. It's 1, 2, or 3 refrigerants with different boiling points. So one's going to leak out faster than the other. So if I had a half a charge of refrigerant still left in the system, it may only be one of those refrigerants. The other one already leaked out. So you start trying to put some refrigerant in to top it off to bring it back up, you just made another refrigerant. So when we start seeing the refrigerant has leaked out, where we would go and top it off, add a little bit of refrigerant to get them going, we're going to pull out what they've got, put in new refrigerant. Yes, sir.
And you're going to see not only the tools change, but we have to have refrigerant leak detector devices in the evaporator coil. That's going to come out where it will shut the system down and will not allow it to run if there's a leak.
Because
It's slightly flammable.
It's slightly flammable. Large concentrations. You get it inside the evaporator coil, a lot of concentration there with the heat strips.
Right, tell me, is it labeled combustible or flammable?
Flammable.
Flammable.
Yeah.
That's worse than combustible.
Yeah.
A2L would be, A2 would means it's flammable. L means lightly, so it's slightly flammable refrigerant. They say it burns like wet wood. So trying to set it on fire, it doesn't sustain a flame, but you get enough concentration and you can actually. Hell, the refrigerant we got now, if it blows out a compressor, the oil in there will cause a flame. I mean, you guys know that.
Yeah, I've seen it burn up.
We're gonna see a lot more of the same of that, but we're not gonna see like butane, where it would be an A3, where it's just gonna catch on fire and blow out.
Yeah. All right, so here's the nitrogen regulator I was telling you about, the VN650. This is a valve that you don't have to manually turn the regulator. It's got preset regulations for purging, brazing, pressurizing the system.
not only that, that's my next purchase.
There you go. We
My
stock
buddy
them.
got one.
Yeah.
You can hand tighten it onto the nitrogen bottle. You don't have to get out of it.
Right. It's got that big thing on there that you can tighten it on by hand. It's got a pressure gauge on it, tells you what's in the bottle. And then as you can see there, you've got test. That's going to be the highest pressure, 650 pounds. Purge, braze, and
the other
off.
thing is the gauge is built onto the regulator itself instead of sticking up out of the regulator.
And it's got a rubber thing around it.
If your bottle flips over, you're not busting the gauge on the regulator as easy as
We need to get him as a
style.
spokesperson for our VN.
Look, they're nice.
Yeah. Recovery machines. Remember, if you're going to buy a recovery machine, if you're going to buy a vacuum pump, make sure they're all rated for the A2Ls right now. Because you're going to see, and I've already seen it like on Amazon, places like that, people dumping them out there, real cheap. Brand name stuff, real cheap. But it's not A2L approved. So if you buy something high, real high dollar now, like a $1,500 recovery machine, you got it at a really good deal, half price, but you can only use it between now and.
How can we find an A2L approved?
It'll say it.
It'll say it. All of the Appion, the JB, Field Piece, they're all putting out nothing but A2L stuff right now.
All of the fuel piece gauges that you have, the A2L refrigerants are already built into that, so that if normally you would go for 30 or 22 or 410A, now you can go to the 40.
Right, and if you bought a set in the past 5 or 6 years, it already has 454B on it. Because 32 and 454B is not a new, right? It's been around. 32 has been used in Europe and other China and all these other Asia in mini splits. They use it right now in mini splits, all their stuff. So that's another thing. Mini splits around. All of our mini splits are probably going to come with 32. Yeah, these little blue things here. Thank you, Rick. These things are devices that you put on your bottle where you can take refrigerant out of the bottle in liquid, but you're putting it in the system as a vapor. Basically, it's a metering device. It's a little bit slower to put the refrigerant in, but you will not flood your compressor. There's two different ones. There's one, the 1/4 inch. We stock that at the branch. You screw it onto the bottle or on your manifold gauge, and you dump liquid in there. When it hits this device, it's into a vapor. You can see there's a lot of field piece stuff on there. I'm really fond of field piece. Field piece is one of my favorite tools. They do a lot of good things for us in trade school. So thermostat wire, as we talked about a while ago, 18 gauge solid thermostat wire. So to start up, we just got to go through and make sure everything's set up properly. We have here's the heat pump setting here. So this is a heat pump with a regular 24-volt thermostat, regular thermostat wires, all that. The app can be connected to this unit to set up all the things like airflow, time delays, airflow delays, and different CFMs on the unit. Now we use the B terminal because we energize in the heat mode on our heat pump. So keep that in mind too. We're a little different than most. Whenever you get to the unit, you're going to see this tag on like the furnace or air handler. So this is the contractor app. We have already ran into this, but you have to have an iOS 13 or later device or an Android 7 or later device. So your iOS software has to be at least 13. So getting into the unit, connecting to the product, you're going to go in, open your Bluetooth app, and click the setup button. When you do, you'll see the pieces come up. Air handler, furnace, condenser. You'll see the model and serial number of the pieces come up. That's how you determine if you have more than one piece in the house. Let's say you have two systems and you're setting both of them up. You go by the serial number so you know which one you're changing the settings on. Within 45 seconds of power being applied to the Econet controller, it will detect the indoor and outdoor units. It's always a good idea to turn the outdoor unit on first on an inverter system, especially the mid-tier, because what's going to happen if you apply power to the thermostat before applying power outside, you will get a code that says it can't find the outdoor fan motor. That's because the inverter is not on. You don't have power to it. In order to cure that, what you would do is go to your Econet thermostat and reset the defaults in it and shut it down, pull it off the wall, then go turn the outdoor power on, the indoor power on, and then plug the thermostat in. In that sequence. That way we're assured that everything's powered up by the time we plug that thermostat on. And it'll see that unit. So just keep that in your mind if that happens, because that's not in the presentation. The equipment adjustments can be made through the thermostat if you have an Econet thermostat on it. Bluetooth settings that you're going to be able to get into are going to be all diagnostic stuff. Okay? All the setup, if you have the Econet controller, is going to go through the thermostat. Whenever you log into the condenser, you can turn the condenser into charge mode. You see the RP16s here. You can, on the outdoor unit, you open up the app on your phone, you go to diagnostics, you click charge mode, it turns it into charge mode. You no longer have to go to the thermostat to do that. And if you have the system that doesn't have the Econet controller, that's where you're going to turn it into charge mode on your phone too, because the indoor unit doesn't have that capability at that time. So whenever you're doing this, you're going to be able to see what's going on outside. You'll see the suction line temperature, you'll see saturation temperature, and your suction pressure. Pressure transducers are sending that information to them. And there's also a cool charge mode along with the heat charge. So whenever you get it into charge mode, you leave this screen, it will take it out of charge mode. So just be sure that you're keeping it on the charge screen whenever you leave, because if you take it out, it's going to throw this warning out. When you say yes, it's going to kick it out of charge mode. And you may not recognize that while you're sitting there charging it. Now, the other thing is, we always talked about the best way to charge a system is the way to charge in per manufacturer specs, right? But doing that, we want to be sure that we're not flooding our unit back with liquid now, okay? Because if we fill it up with liquid and crank it up, then it's could be a goner. So we want to let it sit down and rest a little bit. All the refrigerant finds its way. When you open up the line set, open the liquid line first. Let all that liquid flow out of the condenser through the liquid line like it's supposed to, and then open up the suction line. At that point, then I would turn the system on, and I would not weigh anything in. I would use the charging chart to verify the charge at that point. Okay, you still can weigh it in, but remember, we're dumping liquid in there, and we don't want to do that.
How long should we let it sit? If we replace a compressor and weigh in.
And you weigh in the charge, I would leave that compressor powered up for a couple hours. And then a lot of the compressors, like the Copeland scroll compressor that runs off the contactor, not the variable speed one, but that one has a single pole contactor, and it leaves that one line hot as an internal crankcase heater. It keeps the winding hot. So that's going to take a little while for that to get that liquid out of there. So just be careful, because I've seen them. You might get lucky and hadn't had the problem, but that one time is going to get you.
It's not going to happen so much on most of our days, but there are colder days that you're out there working on it. Those are the ones to be cautious of.
So, I would, my sequence of installation would be, I would go and I would turn on the power outside. Almost the first thing I do. That gets that compressor going with the heat, right? I would solder everything in. I would let the refrigerant flow through my lines while I'm doing my duct work. That way, we have that time to sit there and let that thing heat up and let the refrigerant get to go where it's going. Most of the time that I've seen, you open it up and crank it up. Let's open it up and leave it. Do your other stuff, do your duct work, and then come back and start.
If it's a warmer day and the refrigerant lines are in the attic, it's all going to boil off pretty quick anyway.
Oh, yeah, on a hot day, but if you get that cool day like we've been having, it might not, On the outdoor unit is a chart called a charging chart, okay? It's going to give you the target subcool that you need to run with that matchup. One of the things you have to pay attention to is, as you can see on this unit, this is a 2-ton unit. It has a UF, an LF, a DF, and an RF. All right? This means upflow. This means left flow. This means downflow. And this means right flow. On this chart, everything is really close. You see the different subcool I mean? But on some of them, you have a drastic difference, especially in the heating mode. Let's say we're charging it in the heating mode. Our target subcool here is 22. If it's right flow or downflow, it's 36. See the difference? And the reason is because what do we do when we change it to right hand? We take the coil out, we spin the coil around 180 degrees, and we slide it back in. Right? So now the air is entering the apex rather than the other side, right? It's entering the A part, even on the end coil, it's entering the top, and that makes a difference in how the refrigerant boils off. Okay? So pay close attention. Some units are not going to not even have mentioned left hand or right hand. And it'll say all coils. And that's okay. That's fine. No matter how way it's going, some of them aren't affected. But this one, as you can see, is drastically affected here in the heat mode. While we're charging this in the cooling mode, we want to verify that we have a left-hand unit and we're running a 14 degree subcool. And then we come down or up to this chart and we look at our outdoor temperature at 82 degrees. 82 degrees. This is a target of where we're going to be running. Of course, we know that it all depends upon the indoor temperature and stuff like that. But we all know in the summertime that can be a lot of difference when we first crank this thing up to charge it. So we got to let it settle down a little bit, let it pull the humidity out, because a real wet coil is going to, the pressures are going to be different on a wet coil, because we're actually blocking airflow through the coil because of all the water on it. This is a very good chart to go by to verify once you're done, even if you've weighed it in, you come and verify it with this chart. Make sense? So Bluetooth setup, this is my favorite thing that they did. And the reason why is, this is what I talked about earlier. You put the flashlight in your mouth, you stand on your head, and somebody's reading the directions to you, or you're looking at it yourself trying to figure out which way to turn that switch, right? That's all gone now. We don't have to worry about that. Once we get into the app to set it up, we go into setup, and you'll see the pieces that are there. You've got a condenser with a furnace. You'll see those two. You have a condenser with an air handler. Or if you have two systems in the house, you're going to see them all. Like I said earlier, though, go to the serial number on the unit. Make sure you're connecting to the right one. Now, if you have an EcoNet thermostat connected to it, you're going to get this message out saying that it found an EcoNet stat, and you need to finish the setup in that stat. When you get in to set the thermostat up, if it's not an EcoNet thermostat, then you can go in and set stages, things like stage, the tonnage. You can go change things like the heat rise on your gas furnace. How many of us have ever adjusted the heat rise on a gas furnace? We know they don't come set at the factory, right? We know that the gas pressure is set somewhere, possibly right. But we don't know, so we got to check gas pressure, and we got to check the temperature rise on the furnace, as long as to see that we're in parameters. You can see if we're side return. You'll have to change this to side return because it changes the characteristics of the blower. And then 7 degrees or 12 degree rise, we can go up 7 degrees or up 12 degrees. That means we're slowing the fan speed down. Most of our furnaces is in the 55 to 65 degree range of. This is where you can change it to, and I'm going to say this, and I don't mean anything negative by it, but if you have an elderly couple that's used to that really, really hot air coming out of the furnace, and a lot of the old furnaces put out a lot more heat than the 80% or 90% do today, that's where you can adjust this to, because they're used to that heat. You slow the fan down and get it hotter for them, right? Advanced settings. On a heat pump, you can go set the defrost termination temperature. It comes right here at 60. I would leave it there. For our area, we don't need anything more than that. But it is adjustable for you to do. If you add an EEV there, you can adjust the EEV on the outdoor unit. You can adjust the subcoolant. I would leave that where the factory set it, because air handler, we can do the same type advanced settings. One of the nice things about this one is, once you go into the advanced settings, you're going to get this warning code. And basically what it's telling, if you don't know what you're doing, don't go there, right? So you say yes, you get in there. Now you can adjust your cool trim, your heat pump trim on that unit. So it means when I say trim, we can raise or lower the airflow in 5% increments to 25 degrees minus. So because you may have a unit that's putting out 1,312 CFM like that one's doing, and today we're not going to have much dehumidification on a 3-ton unit, right? At 1,312 CFM. So we need to drop that down a little bit to get it below probably about 1180 or somewhere around there, so we can get our 350 is basically where we want to stay down here. 350 CFM per. Well, I mean, it works. You get a lot of sensible cooling out of it, but you don't get any latent. You know.
You can tell the difference.
We can change our blower time off delay. I would take this right here and move it to 0. Because the last thing we want to do in our area is put more moisture back in the air. And whenever the condenser shuts off and that furnace is still, or the air is still running, we're pumping humidity. So go shut that to off. That's the first setting that I would do right there. Turn it to off. You can adjust the staging timer from 10, 15, 20 minutes to stage from high to low. And then we also have the trim features here. Outdoor settings, you can see defrost settings here. Defrost termination set at 60. Let's go into the system status screen. So we can go into there and see, we've gone through the Bluetooth setup. We've gone through some diagnostics. We're at system status. So let's look at what the system's doing. We log into the unit, go to status. Now we see our air handler, our furnace, and our condenser. Now we can see what's going on. We can see that our compressor desired speed is 2,000 RPMs, and our compressor actual speed is 1,960 RPMs. So we're running pretty close to what it shows it needs to be at that point. Our outdoor temperature is 78, our liquid line temperature is 70.2, our compressor temperature is 70.2. So looking at the air handler, it's actually telling us what the unit is commanding the airflow to be here. See, 1200 CFM, and the airflow is 1200 CFM. Our current RPM is 1295. That's a problem. If you ever see that, that means you're running high static, because the maximum RPM of that motor is 1295. And we never want to see it hit max. Okay? When it hits max, that means that every time it hits that max, it hits a limiter, and that limiter backs it back down. Then it goes back up to that, and then back down. So what that's going to cause is the motor to go out prematurely.
On these, if you order a motor, does it come with the module, or is it separate?
No, it comes with the module.
Okay.
This one does.
Okay.
Yeah. The condensers, remember, they're operated without the module because the board sends that signal.
Oh, you're talking about.
Yeah, these are this air handler. So keep that in mind. I mean, it's showing your static pressure, but I guarantee you that static pressure is not 0.05 right there. No way. That's probably pushing 1 inch of static. And these things will tell on you because it's going to tell you your static pressure. It's taking the torque and the RPM of the motor and determining what the static is. And it's pretty close. I've measured with my gauges, and I've measured it with looking at the app, and it's pretty dang close.
It'll give you an alert?
Yep. When you first turn the system on, if you have it on the EcoNet controller for sure, it's going to give you an alert code. It'll go away. And then it will continue to operate normal until it reaches the higher CFM as it saw before, and then it's going to throw it again. It may not throw it for a month, but if their filter starts getting stopped up, it's going to start throwing it. Blower cutback's going to go in, and you're going to have all kind of problems. That goes, like you were talking about earlier, about that undersized duct system. These units are smart enough now to tell you that you have an undersized duct system. Your homeowner is always going to tell you, well, the other one worked just fine. If you have an EEV, it's going to tell you what the position of the EEV is in. This is the air handler, basically the same information, only it tells you what the KW, if you have the newer heat kit in there. It's going to give you the KW of the heat kit. It's going to tell you how many alarms you have in the system. It's also going to monitor your auxiliary, too, for you. A drain pan switch trip, it's going to tell you that switch is tripped there in the status screen. How many of us chased our tail around for a little while? And I'm not going to lie to you and tell you I haven't. I've gone through a job and chased my tail around for at least a half an hour to figure out I had water in the pan. I've done it. Everybody's done it, I'm sure. It's going to tell you what motor you have, and it's going to give you a software version. This is important to us. If we're having some goofy things happening here, I'm going to want to know what software we're running on that air handler board. I want to know what software we're running outside, software we're running on the thermostat, just so we can see if maybe we didn't have a bug in that version, right? And I have the capability to come out and reprogram these boards if we had to. Most of the time we just tell you to change it if it was a problem in there. But if I'm on the job and I have my stuff with me, I can reprogram it and it wouldn't be a problem. Furnaces are the same way. As you can see, it tells us our supply air temperature, our return air temperature, so it's taking that split for us to tell us our heat rise. And then we have a place for all of our sensors and everything to hook up. And there's our auxiliaries there. That's our flip switches. And it'll tell us if we have an active call on cool or heat or cool, whether it's high or low. It tells us our inducer's running. So how many times you're going to have to go up there and listen to see if the inducer's coming on? No, not anymore. You go to the thing that tells you the inducer's. Flame sensor tells you what kind of flame that it's active. In other words, we've got fire. And whether our pressure switches are closing, our limit switches. Here's our limit switches. Our flame sensor strength. The flame sensor is a electronic communicated device now. It's no longer check your microamps. It comes back as like a digital signal back to the board to tell you what strength you're running, whether it's normal or low. So you can't check it the old-fashioned way anymore. But the app's going to tell you if it's the flame sensor or not. It sees your limit switches, and it gives you current alarm count. It means how many times it's gone out on alarm. And, of course, the software version again. Outdoor unit status, again, cool. Outdoor desired speed. Our actual compressor speed is at 45% with a 2,000 RPM on the compressor. Outdoor temperature, liquid line temperature, compressor temperature, and over here is all your pressures. It tells us what our voltage is coming into the unit, how many amps we're pulling, what the current is, whether we're in a hold timer or not. Then this is where the utility can hook up to it, the shedding that we talked about earlier. And if you had an EEV, it would tell you your position of that. Suction pressure, saturated temperature, all the stuff that we need to normally go to our gauges and get is right there on the control. How simple is that?
Tells you everything you need to know.
Pretty much, right? I mean, you can go there and open that up and tell, before you even put your gauges on it, what you got to get out of the truck, basically. Furnace operation, air handler. This is the operation sequence of the unit. Inducer, the thermostat says to start, the inducer starts. The pressure switch pulls in, the igniter starts doing its thing, then the gas valve opens up, it proves flame, and now we're heating, right? And we do the same thing again after the end of a cycle. The heat pump will run at high speed when the following occurs. You know, our outdoor ambient temperature is 95, or the outdoor ambient temperature is below 32 degrees. Saturated liquid temperature. A lot of things are going to affect what speed the unit runs in. If the saturated temperature below zero after 15 minutes of runtime. We have our pressure relief valve in the unit. It utilizes suction pressures. Rotary compressor, so it equalizes the compressor like we talked about earlier, so the compressor will start. We want to start with less than 20 psi across that compressor. If it's more than 20 psi across it, the lockout timer will hold it for 5 seconds before it starts and give it time to relieve that pressure. Outdoor fan cycle, it's on at 80 degrees and off at 64 or 40 psi, so we're cycling that fan outside. This is one thing I always tell you, remind your customers, let them know this is going to happen. Because you're going to see them out there at the pool or on the barbecue or whatever they're doing outside. They're going to be outside, and all of a sudden this unit's going to ramp up to 2,400 RPMs from running it slow for 2 minutes, and they're going to go, wait a minute. Then it went back to low, and they think it's broke. Explain to them that, occasionally they're going to hear it running in low cycles, and then they're going to hear it pick up. That's so we can get oil back. Running at low capacities all the time will push a lot of oil out into the system. So we have to ramp up the compressor to suck it back. Okay? Let them know that so you don't have these nuisance calls. Defrost, this is what happens on defrost. The outdoor temperature is below 35 degrees, the compressor has operated for at least 34 minutes, and the outdoor temperature is below 35 degrees, that's when we're going to get defrost. That's when it's going to initiate. If the outdoor temperature is 35, but it hasn't ran for 34 minutes, it's not going to even look at it, right? So basically on a defrost cycle, the reversing valve is de-energized, the outdoor fan motor is de-energized, and auxiliary heat is energized. Termination is just a reverse cycle. Reversing valve energized, the outdoor fan motor energized, and electric heat is de-energized. And it returns back to normal heat. The mid-tier operating RPMs are as if the unit's running on the drive, it will ramp up to 70%. If the unit is on the line, which means it's running through the capacitor, it's going to run at 3,400 RPM, which that's where it hits high. Okay, that's the maximum RPM of that compressor. The outdoor temperature thermistor on the ODC, it will defrost every 34 minutes at operating coil temperature of 35 degrees below. And then terminate again at 60. This is where your difference comes in from the EcoNet controlled unit or the two-stage thermostat controlled unit. So as you can see, as the unit is running, based on demand, at 45 to 70%, we're running like a variable speed compressor. Once it gets up here to say, I've got a call for Y2, it's going to turn off the inverter and energize the contactor. You're not going to be able to notice that's happening, but it's going to.
So it don't stop and start.
No. Compressor's just going to pick up at high RPMs. It switches. Here we're running on time. I mean, it's just running, right? We're maintaining temperature. If it gets outside the parameters, then we turn it on high to get it back down. It's going to run it at high speed until the end of the cycle, and it's going to start off again, running like this. 45%, and make its way up to 70, and then bam, line voltage comes in, it goes up. 45%, it can run up to 70% here. It's just depending on the time it's running.
Okay.
As it runs longer, the faster the speed it's going to go, because it can see the load. But once it gets to that 70% is whenever it swaps over to the contactor and it picks up the high speed. Now, we call this a three-stage unit because if we put it with a thermostat, a regular 24-volt thermostat, then that changes the algorithm of what the board's going to do. We go from 0 to 45% in 10 minutes. Okay? So bam, for 10 minutes it's running here. After that it's running here, 65%. And then after that it goes up to 100%. So we get off the inverter at this point. There's first stage, second stage, third. Make sense? Put the EcoNet thermostat on there because it's going to make the unit a lot more efficient and do what it was really designed to do. It cannot stage down from line voltage, so that means it's going to run until it cycles off. So as you can see, here's your savings. On the EcoNet enabled driving, here's your comfort settings. As you can see, the compression is going up and down. It's modulating. As it'll come down a little bit, and then it won't go into full capacity until at 70%. So we're gonna be running down here in our comfort level. After it runs 10 minutes, it's gonna say, we need to go up a little bit. So it's gonna make its way up to here. So let's look at diagnostic codes. Now this is where you're gonna want to make sure that your phone is tied into the Ruud or MyShare Comfort app as your contractor, because this is where you're not going to have a lot of stuff. You're not going to be able to get into alarm codes. You're not going to be able to get into schematics, wiring diagrams, specifications.
I was going to ask you, is that something our TM sets up for us?
Yes, sir.
Okay, so
Yeah.
that's give you, John.
Now you can start it off by going to, are you Sure Comfort or Ruud?
Sure Comfort.
Go to mysurecomfort.com and set yourself up an account, and then not as a contractor but as just a user, and then tell John you did that, and they'll get your email address, and they'll go tie that together. And then so your login for your contractor app and your MySure Comfort is going to be the same. As soon as you log into it, if you have service techs working under you, the administrator of the account, you would have access to go add them in. Okay? And you can remove them. So on this one is locked out on several error codes, one of them being A953_O. Now that _O is important because that's telling me that it's an outdoor unit. If it was in the air handler, it'd be _A. So I know now I'm having a problem with the thermistor. We also have one for a missing inverter communication failure. We might not have 240 to the inverter. If you have 24 volts to the inverter, the lights are going to be on, but you don't have high voltage to it. Or vice versa. You could have high voltage to it and no low voltage to it. So always check your fuses, because usually it's a blown out fuse. Here you see over here on the side the O, A, F, C communication. Z, if you had a zoning and you had airflow problem with the zoning, you get an _Z on the end of it. If you click this on this app, if you've got an account where it ties to your Sure Comfort or Ruud app, and you have this, you click this, it's going to take you into this. This is the code that says, okay, this is a suction line thermistor on the outdoor unit on the suction line. It's reading out of its parameters. Here's your parameters it should be in. If it's reading out of your parameters, then the fix to this is change that sensor. It's all going to be there. It's going to basically point you in the direction that you've got to go to help you diagnose the problem with that unit. On the Econet control, here's where you have your alerts. You can go see alerts. You can go see alert history. You can click this button and go see equipment. I encourage everyone, if you're having a problem with the unit, click on equipment, take a picture of that screen because it's got every board on that screen. It has the serial number of that board. So I can tell you if there was a problem with that board or not. And then you go to your alert and take a picture of that screen. Call me then. Okay? Now I know what equipment's in there. I know what revision the boards are. And I know what the error code is. Makes it easier and faster for me to help. The lockout timer, this clears the lockout timer. Manually do it on the thermostat or on the app. The Bluetooth antenna, of course, is, like I said, kind of delicate. They tuck in there on the board. But while you're installing it, make sure it don't get hit on any metal or wires where it's going to pull it off. This is another one of those screens that's important for you, I think, for servicing the unit. So take a picture of this. This is the other Kodak moment. This is going to help you determine if you have a communication problem with any piece of equipment, whether the outdoor unit, the air handler, or at the thermostat. So you're going to measure your voltage on E1 and E2. You should have 3 volts DC across those two terminals. Then if you go to E1 to common, you should have 3 volts DC, solid 3 volts DC. If you go from E2 to common, you're going to have anywhere from 0 to 0.2 volts DC. That's your communication happening. If you don't have a fluctuation, or if you don't have the voltage here, you've got a bad communication wire between this component and wherever it's at. So go to the next component. I would take my wires off of the outdoor unit and go to the next component and check it, then pull them off that and then go to the next one. That way you eliminate if you had a short in the outdoor unit that was causing you to have communication problems, taking the whole communication circuit down, at least you just eliminated that one, right, from doing that. Basically, check it with it connected and without it connected, and that's going to tell you where's your problem. If you've got to splice it, yeah. It's like, especially if you're going to do it in the middle of a run, because none of us want to get up in that. Because this is the first thing I'm going to have you do. I'm going to say, go take all your wire nuts off, cut the wires, restrip it, and put them back on. Okay, so next here we've got this. How many times have I said this today? Don't push the button. Do we ever push the contactor in? No, we do not, because we'll let the magic smoke out, and there's no smoke boxes available to put it back. Okay, it's impossible to put it back. So we never want to push the contactor in because that makes a direct. We do need operating voltage between L1 and L2 coming into board between 197 and 253 volts AC. If we have higher than 265, we'll generate an over voltage code, which will shut the unit down. Guys, once we get to 165, we've burned up a lot of stuff already going. They're going to have light bulb problems. They're going to have motor problems in the house. Below 187 is going to throw an under voltage code. Normal compressors won't start if the voltage is close to 187. You know, we have a hard start kits. You know, even those won't start. These units will. If our voltage is down to 195 volts, it's going to work. You know, external surge protection is recommended. That means a surge protector. You can get a surge protector for about $80, under $100. It's very good insurance. Is it going to protect you from a direct strike of lightning? No. Is it going to protect you from all these spikes that may happen? You know, even during a lightning storm, something may hit close by. Tree could fall on a power line, right? And short out, throw more voltage in there we need, and it's going to kill the boards. You know, customers now, they'll go to and buy a computer at Best Buy or wherever, or Walmart. That salesman's going to sell them on a surge protector device, which is a strip about this long, well overpriced of what it does, right? And they're going to buy it because I'm going to protect my computer. I'm going to protect my video game. But when you come to the most expensive appliance in the house, it's overlooked. But what's inside these units? What's that? That's a computer, right? An expensive one, right? So, yeah, let's sell surge protectors, guys. Hey, it's going to pad your back pocket because you sell it, you make more money, right? Included in all the jobs. And that could get you the job. If you're out there selling against someone, you said, look, I put surge protectors on all of my equipment that has a control board in it to protect that control board. The other guy might not do that. To me, if I was told that, that's a job. I'm going to get it. Hey, he's $200 higher, but, hey, man, he's throwing surge protectors on here. I'm protected. Unit cannot go from inverter to line voltage without synchronizing the wavelengths. 60 hertz, right? As that unit's flowing, we're flowing from 40, 45, 50 hertz. It's got to synchronize the wavelengths before it changes. So that's why it gets up to that 65%. And 70%, the waveforms are close, bam, it switches. So it cannot do it. So anytime that we try to speed that up manually, it's going to be a bad outcome. There's protections in there against this happening. So if for some reason you have a blip in the voltage or something, it's going to kick the inverter out. And it's going to go into a time delay. So all that's in there. Connected directly to the inverter is the automatic reset high pressure switches. The suction transducer. This is what permits different operating ranges. So you're going to have the compressor going up and down. It's going to see the pressures in the system. So it's going to ramp the compressor up, ramp it down. This helps tell the board what the system's doing. There's two different transducers there. There's a suction and a liquid transducer. The liquid transducer permits different operating range too. Now it's going to open at 610 psi. That's your pressure switch basically. When it gets to 610, the transducer is going to say, kick it out. This is what a transducer looks like inside. It looks like a pressure switch basically, only with 3 wires. We have common, and then we have our input, our output. So we'll have 5 volts going in and anywhere from 0.4 to 4.5 volts out, depending on the pressure. You can actually tell what your suction pressure is if you have the chart by checking the voltage. It's going to get you really close. There's a Schrader valve in here, so you can replace this under pressure. Some of the things that I've ran into at least one time in my career with these units, we had a compressor that we were on our second compressor, fixing to be third. We kept losing compressors. Every time we would go out there, everything seems to be running fine. So I got called out to the job because he said, man, we're fixing to lose this compressor. So I got back out there. We started looking. First thing I started doing was looking at the pressure transducers and the thermistors. I found that the suction transducer on the indoor evaporator coil said that the pressure was 97 pounds pressure. My gauge said it was 154 pounds. I'm like, what's going on here? So that's going to change what the expansion valve does, right? I pulled it off. The salesman was with me. I said, hey, go down the branch and get a new pressure transducer. While he was fixing to leave, I was taking it off, and I didn't hear any pressure come out when I took it off. So I shined my light inside there where the Schrader valve was. The Schrader core stem was bent.
Oh, wow.
So when you screwed this down, it wasn't touching the Schrader all the time. So if you turned it off, temperature difference would make it push it, and it would put pressure on it. So I had 90 pounds on it, but there's in here inside the coil was actually 150 pounds, right? So there's just little things to look at, because that caused 2 compressors to go out. Between the 3 wires, you're going to go from the black and the red wire. The red wire is going to be your power. You should have 5 volts DC there. Between the black and the green wire, you'll have anywhere from that 4.5 up to, or 0.4 to 4.5 volts, depending on the pressure that's in there. Here's what the chart looks like. So if we're seeing 2 volts on green and black, we're approximately 112 psi. I was reading this, but I was actually up here. But the pressure transducer was telling me different. So that's how you can tell if you got a problem. Now, this chart can be found on the Coburn Connect app. We have it in there as a calculator. We have one for the liquid transducer and one for the suction transducer. Whenever you connect to the contractor app, you're able to go see the thermistors, the readings of your thermistors. I would go match these up too, and then check them to make sure that that's what it's doing. The best way to check a thermistor is a cup of ice cold water, ice water, a lot of ice. Drop the thermistor down inside and you measure it. Should be at 32 degrees at that point, thereabouts. You can go to the chart that we have on the Coburn Connect app, and you can go and find it. You can go to 32 degrees and know that what you're supposed to read at 32 degrees on your ohm reading. So you check it that way. You can also put a thermometer right there where the thermistor connects onto the coil. Check that and see if it lines out to where you're at. May not be exact. It may be a little bit of ohms off, but it should be pretty dang close. Discharge line temperature on the outdoor unit, if it reaches 235 degrees for more than 30 seconds, it will display a fault code that says discharge line temperature high, and it would be followed by, of course, D_O. But the compressor at that point will lower its RPMs until we get below that 200 degrees. And we fall below 200 degrees, it would go back to the command speed. If it continues to do this, that's when it's going to throw that code. If it doesn't line back out after it goes down to 200, then it goes back to the command speed. If it goes back up again, then we're going to have problems. with the thermistor or something, or charged possibly. Could be undercharged. This is just a schematic that tells you where all the thermistors are located on the board. Of course, it was marked like it was before on the board to tell you where it's at. This is the Hiley compressor. This is the twin rotary. This is what it looks like on top. It's got an internal overload. I hadn't got the question yet, but I'm going to go ahead and throw it out. It's not a variable speed compressor, but yet the board is treating it like a variable speed compressor. Has anybody seen those devices that ICM controls sells, where you can take a regular PSC motor and turn it into a variable speed motor? That's basically what's happening.
Jody, we've had that same thing with our condenser fan motors for years.
That's right.
You put a 5 microfarad capacitor on there, it becomes 1 horsepower. You put a 10 microfarad capacitor on there, it becomes a different horsepower. All those different capacitor changes
work in the same exact way.
And that's exactly what you're doing here.
We're changing the capacitance on the motor. You should read what you would normally read on your ohms readings on a compressor here. You know, on a 3-phase compressor, you read equal on all 3 legs. Here, you're going to read like you do a regular capacitor-driven compressor motor. On the outdoor fan now, the other question hadn't come up yet, but I'm going to wait to the end to see if it does. But the outdoor fan motor works off the inverter. So even though the contactor's pulled in, the inverter is still controlling that motor. Didn't get the question, so I'm going to throw it out there too. Can this unit run on just the contactor? Can we bypass the inverter and run this unit if the inverter's bad? We just run it at high speed. Answer is no, because the motor runs through the inverter, so we wouldn't be able to run the motor. And it runs off a PWM signal, so we can't jump it out. The answer to that's no, so we don't go on to reinvent the wheel. Is there a way? Someone will find a way to rip all this stuff out and make this unit run normal, right? Like a regular system. But I don't want to be involved in that. Here's where the discharge line solenoid hooks up, equalizes the pressures across the compressor. Common code you could see, missing inverter, COM code, that's A29_O. I see that a lot. That's if we're missing the 240 volts outside for some reason. Communications lost with the indoor unit A111. I see that quite often. That's normally because we have a broken wire or a pinched wire, something shorted out somewhere. A906_O compressor lockout. We do occasionally see that, and most of the time it involves a thermistor bad or short cycling or something like that, where the compressor just gets, it sees something that's going to hurt it. And then pressure relief valve stuck closed. Of course, this is a new one. I haven't seen that one yet. Discharge compressor high. I've seen that. You'll see this whenever you have an undercharge. You know, our discharge line starts getting really hot. Our condenser coil's dirty. Something like that. We see that a lot for that. So if we have a A929_O, that means 240 volts is missing at the inverter, and it cannot communicate with the drive. So we need to check line voltage to the outdoor unit. Verify that we have proper voltage from our mod bus over to the inverter so it can communicate. That's that first picture you guys took, right? Want to verify the voltage at the indoor unit and outdoor unit, verify the wiring between the 2 units, and then verify the correct wiring, and then if all that's good, you've checked it, it's doing what it's supposed to, then at that point we'll change the board. But I've seen a lot of boards change, and I get the call, man, I've changed that board, and it's still doing the same thing. And it all boils down to that one dang wire that was broken. So if we have this A960_O, we want to check the compressor winding resistance relative to ground. If you have a grounded compressor, I have seen one of these compressors run with a grounded compressor. Yep, it had a grounded compressor, and it was running. But it would just overheat really fast and go and cut off. We want to, at this time, check the compressor, check all the windings to ground, check them between each other. If all the problems out there is okay, if you don't see anything with the compressor, then we're going to look at replacing a board, you know, the inverter board, possibly. But I've seen when I say I've seen this, this is on a true variable speed compressor, where I've seen it grounded one of the legs. Normally, when you have a leg grounded, it's gonna short out, right? But it goes through that inverter, and that inverter is pushing that voltage through, and this still was grounded. So if we have a TO11_O, this is the relief valve that we talked about. It's either stuck or it's not getting the proper control voltage. T972_O, discharge line high temperature. We want to check and make sure the coil's clean, number one, right? We want to look at the outdoor fan, make sure the fan's running at the proper speed, and you can do that through the app, right? See what its target is and where it's running. Then we check the sensor to see if it's properly reading by placing the place the sensor in ice water to make sure it lines up on the chart at 32 degrees. Let's look at troubleshooting on the indoor unit. Makes it so much easier on a gas furnace, as we talked about earlier. You look at the LED lights, look at the status on the LED lights, you can tell what the furnace is supposed to be doing, whether it's in heat or a fan or if it's off. So no illumination, no LED, not sensed in the app, flashing open connection, solid connected. So that's what your Bluetooth lights are telling you. The flame sense has to be diagnosed through the contractor app like we talked about a while ago. You go through here and you see the strength of the flame sensor. If the unit is off, it'll say off. There's a high, normal, and low. You can't check microamp. If you do have a flame sense problem, you can clean it with some steel wool or something. Don't put sandpaper on it. If that doesn't fix it, then you want to replace it. You can see all the alarm histories, current alarms in the EcoStat or on the app. Here's the typical wiring between the board and the indoor blower motor. As you can see, it looks like a regular ECM motor, 1, 2, 3, 4, 5 tap, but they're all hardwired into the plug and plugged in where you don't have to move it. That's because we changed the speed of the motor with what? The app, right? So we don't have to change anything. We can still check it, though, to see if it's putting an output on that particular terminal. So looking at the PWM signal that comes back from the motor, so as you can see, the blue wire is what sends the RPM feedback. Of course, we don't use terminal 4 is used for only the 24-volt control back. It should be always present to the motor. The rest of the wires are communication wires back telling us what the motor is doing. A T117, that's detected not hitting the RPMs that it's supposed to hit is what this is trying to tell you. So you can go back and check it through your wires and make sure you have the correct voltage, correct feedback coming back from the motor here. This is the ways that you can determine what the values of what the torque is and where it's working at as far as percentage of capacities. Well, thank you for joining us today for this video. You can find more of these type videos on Coburn's Connect app or on our YouTube channel. Hope you enjoyed it, and don't forget, if you have any questions, please contact us at hvac@coburns.com, and don't forget to subscribe to our channel. Thank you.